we're gonna go ahead and analyze the beautiful parameters. So with that said, we went over the logarithm definition, and we said that we have an inverse, right? We have a log function, we have an inverse of our exponential function. Now we went over the notions of transforming them or converting them from exponential to logarithm and back and forth. And we were able to use or do these examples here in this case. Now, let me go ahead and evaluate these parts right here, this one right here. So what did we do with this example yesterday? We had this example as part of our exit ticket. What happened to our function here? We're gonna go ahead and rewrite it, and instead of having f of x, what are we gonna write? We're gonna write y. So y equals log base 7x. Girls, which one is our first value that we're substituting for? 49. So we have to make x equal to 49. So therefore, where do I substitute it? In y or in x? In x. So we have y equals log base 7, 49. So how do we rewrite this into exponential? 7 to the power of y equals 49. And what does my y have to equal here in this case? Close. It's 7 times 7, so y equals 2. So my exponent, that's what we're looking for, the value of the exponent, has to equal 2. All right, now our next item. I have y equals log base 7x. What is my x value this time? X equals 1 over 343. So we have a beautiful fraction. What do we say about this beautiful fraction? Our exponent or y is going to be negative. So how do I rewrite this? Y equals log base 7, 1 over 343. How do I rewrite into exponential form? 7 to the power of equals 1 over 343. It's sad here because we made it into a fraction. So therefore, y has to equal -3. This is the one that confused some of us, especially when we had radicals included here. So this one, I'm going to go ahead and write x equals 7 square roots of 7. And I am substituting x into it. So I have y equals log base 7, 7 square roots of 7. Now I'm going to rewrite my 7 square roots of 7 into an exponent form. I don't want that radical. What's another way to rewrite it? Or what's another way to rewrite square root of 7? 7 to the power of? Not 7. 1 over 2, 1/2, because this is a square root. So we have a radical. So a way to rewrite a radical is to change its exponent to 1/2. So I'm going to write 7, and it's multiplying it by 7 and 1/2. So this is my new result. So how do we rewrite this now? 7 to the power of y equals 7 times 7 to the power of 1/2. Whenever we're multiplying two values of the same base, what happens to our beautiful exponents? They add together. So I'm going to write 7 to the power of y equals my same base, and it's going to be 1 plus 1/2. 1 and 1/2, or if I were to write it into a, not mixed fraction, improper fraction, 3 over beautiful 2. So what would be my y? Y would equal 3 over beautiful 2. And you guys had this part of your homework, right? Yes.
Wait, why is it not 1/2?
1/2 is just my, if it were to be just square root of 7, it would be 1/2. But we had 7 square roots of 7. So since we added that extra, we have the same base. So we keep the base and then we add the exponents combined together. Okay, so 3 and 3/2. So this will give you 1 and 1/2. Rewrite it, it will be 3 divided by 2. 2 over 3. All right, everybody got that? Okay, just make sure I wanted to clarify that part. Clear. Everybody have that? Awesome. Clear. Okay. Now I'm gonna go ahead and go into my next example, number 2. Remember that we had exponential functions back then, like a chapter ago. Yes, Ms. Vasquez. Okay. So how do we evaluate the values of it? What do we have to do? Substitute our values. So we have our first value, it's going to be 0. So f of 0, so it's 2 to the power of 0 is?
Isn't it 1?
It's 1. Remember, anything to the power of 0 is going to be 1. Yes. Oh, I have notes actually. Let me give you guys grabbing paper because we're going to grab. All right, so we have our next value. What is my f of 1? 2 to the power of 1, it would be 2. What would be my next value? 4, and the last one? 8. So let's go ahead and graph those points. So 0, 1, 1, 2, 2, 4, and we had 3, 8. And the next one would be 4, 16, and so on and so forth. So we're able to create that beautiful exponential function. So we did this last chapter, last section. Now, today we're going to go ahead and graph our logarithm function. And the definition of a logarithm is the inverse of the exponential function. Now, in order for us to graph the inverse, we have to remind ourselves that whenever we have the inverse, you guys remember what the line of reflection it was? What was it? Do you guys remember? It was my line y equals x. So this beautiful line, I'm going to go ahead and graph this one right here. Now my line of reflection, I'm going to go ahead and highlight it. So I have my little pieces, my dashed little line. Make this better. And I have my line that goes all the way with the slope of 1, and it is y equals beautiful x. So there it goes. All right, so here's my beautiful y equals x. That's going to be considered my line of reflection. Now, if it's being reflected, what do you think is going to happen to these values? They're going to reverse. So for example, let's go ahead and say that this coordinate right here, it was what? 0, 1? What would it be its reflection according to this line, y equals x? 0, not -1. And it's not 0. It reflects like a mirror. What is it? 1, 0 in this case. So my reflection would be at 1, 0. Now my next point was at 1, 2. What do you think it will be? 2, 1. The next one, it was at 2, 4. 4, 2. 4, 2. The next one, 8, 3. And so on and so forth. So we're going to go ahead and graph our beautiful logarithm function. So it's our inverse function. So here is my parent function, f of x equals 2 to the power of x. Here is now my beautiful logarithm function, my inverse function, where I'm going to have that beautiful log base 2x in this case. So yes, we can go ahead and grab our values. Let me go ahead and grab our values. We said that we have them mirrored image. So we're gonna have now 1, 0, 2, 1, 4, 2, and 8, 3. Now let's go ahead and solve it mathematically. So I'm gonna go ahead and pick my first value for x. Let's go ahead and say that I have this right here. X equals 1. So I want my f of inverse to be 1. And I have my logarithm right here that I want to evaluate. So I'm going to make this y equals log base 2 x. And what is my x value here? X equals 1. So let's go ahead and evaluate. Y equals log base 2, 1. How do I rewrite that?
2 to the power of y equals 1.
Equals 1. So let's see. 2 to the power of y equals 1. And we said that no matter what we have as our base, anything to the power of 0 equals 1. So therefore, y has to equal 0. So we proved it mathematically.
You have to do that whole.
No, you don't necessarily need to do this, but I'm just showing you mathematically that's how it works. I can go ahead and do it for the next value too. So let me go ahead and make some space over here. Let's try another number. Pick another number from here.
2.
2, okay, so we want x to equal 2. Therefore, y equals log base 2, add 2. So we have 2 to the power of y equals 2. So what is my exponent? Y equals 1. So does my y value equal 1? Yes, it does. I can go ahead and try it for the next value and the next value and the next value and so on and so forth. And I'll continue to get my inverses. So we have now proved that we have our parent function, 2 to the power of x, and its inverse function is going to be log base 2x, okay? Now we're gonna go ahead and transform that beautiful function, this one right here, that inverse function. Now since we've identified the parts and we've identified everything else. All right, everybody has this? Yay, okay, we're going. All right, ready for the first transformation. Okay, let me go ahead and clear. Here is our next example. Let me go ahead and go over the transformation parameters. So the same parameters still apply. We have this time, we're gonna go ahead and see our base. It's going to be 2. So our 2 base, our base here. And we're gonna have a parameter A. We're going to have a parameter H, our parameter K, and our B is going to stay as 2 for today. Since we have our base 2 or log base 2. So our parameters still apply. Parameter H still moves our function left and right. Our parameter K is going to move it up and down. And our parameter A is going to compress or stretch it vertically, and parameter B horizontally. However, we're gonna go ahead and keep it at 2, like I said. So go ahead and copy this one, our new function. So we're gonna go ahead and now transform our function. So let's see. Last time we had a horizontal asymptote. This time we're going to have a vertical asymptote. So my vertical asymptote is going to be what this value makes it equal to 0. So x minus 5 equals 0. What do we have to do here? Add 5, add 5. We have x equals, beautiful, positive 5. So my vertical asymptote is going to be now at beautiful x equals 5. All this right here. So I moved all my points 5 steps to the right. Now, what is this parameter going to do to my beautiful function? It's going to move it up and down. So it's positive, so it's going to move it up how many spaces? 3. So each of them, we're going to go ahead and move them 3. 1, 2, 3. And then I'm going to move it according to my asymptote. So 1, 2, 3, 4, and beautiful 5. So here's my point. 1, 2, 3, and 1, 2, 3, 4, and beautiful 5. Next one, 1, 2, 3, and over 1, 2, 3, 4, and 5. And the last one is somewhere over there, but here goes my beautiful function. So I was able to grab that transformation. We're just looking at the parameters h and k right now. Not too bad, huh?
Where did it bring out?
To my right, to my right.
Well, how do you get the green arrow?
Because look.
I did this, I just read both through, oh, right.
Yeah, and then you go to.
So it goes up. So it goes up 3 spaces. 1, 2, 3. Then we do the horizontal asymptote. 1, 2, 3, 4, and 5.
Oh, so the 5.
Yep.
1, 2, 3.
So again, 1, 2, 3. And over to the right. 1, 2, 3, 4, and 5. Let's use. My next one is up 1, 3, 1, 2, and 3. And then to my right, 5. 1, 2, 3, 4, and 5. So each point moves up 1, 2, 3, 1, 2, 3, 4, 5.
Okay, that makes sense.
Make sense? Okay.
Oh, but but you told me why this thing was linear, and then we have this line here.
Now, the other one was the line of reflection. I was trying to, I explained the other part was the line of reflection. I was trying to explain the function and its inverse.
Oh, okay, but is every like problem always gonna be the same reflection?
No. That was just the parent function and its inverse.
Oh, okay.
So introducing where the points came from, where the log came from. Now that we have the logs, we're gonna go ahead and introduce the parameters. We have the parameters. We're gonna go ahead and transform them using that h and k, and then transform them. But this time we only have, a vertical asymptote. Last time we had a horizontal asymptote. This time we have a vertical asymptote. Okay. Ready?
Yes.
Okay, let me go ahead and clear. Our last example for today, this one right here. Go ahead and copy this one down. G of x equals log base 2, x plus 4, negative 1.
Also, since we have the y axis,
So these values are what? 0 and 1. So let's go ahead and graph that parent function. 0, 1. 1, 0. And then 2, 1. Goodness gracious. Backwards. Goodness. There you go. 0, 1, and 1, 2, 1. And then it is 0, 1, 2, 1, 2, 4. 4, 2, and then it's going to be 8, 3. Thank you.
yes.
Perfect. All right. Now that we have our beautiful parent function, this is the parent function f of x. Now we're going to go ahead and transform it. What are our parameters here?
So what happened?
What are our parameters here?
-4.
Negative 4 is our
X. The vertical.
vertical asymptote, which is x equals negative 4. How do we get negative 4? We make this equal to 0. So we have x minus 4 equals 0.
So add 4.
Add 4, add 4. Sorry, subtract 4. I wrote it wrong. Sorry, guys. So we subtract 4, therefore we get x equals negative 4. And our beautiful parameter k, we shifted 1 up or down?
Down.
Down this time. We're going to shift it down 1 space. So let's go ahead and create our beautiful vertical asymptote first. My vertical asymptote this time is at negative 4. So here it is. Vertical asymptote. And my figure goes down 1. So it's going to go down 1 and over to my left or right? Left, how many spaces?
4,
1, 2, 3, 4. 1, 2, 3, 4, and 4. Right here. 1, 2, 3, 4. So down goes 1, and then we go 4 to the beautiful left.
Easy.
Okay. I'm gonna go ahead and give you guys some time to work on your homework in class so you guys can work on that. Do not worry about it. So we have 1, there we go. And we have 4, 1, 2, 3, and 4. Down 1, over 4, 1, 2, 3, and 4 right here. And then we have 1, and then 1, 2, 3, and 4. And so on, so forth. It goes on and on and on. Okay. All right, let me go ahead and give you guys your beautiful homework so you guys can work on it. During class, we have about 15 more minutes.